Right, so for this teaching session, I want to talk about a simple framework. I suppose you could say that the first simple framework is the beam. The next one is the triangle. So with these problems we need to put one hinge in and one pivot in. If we put two hinges in, we over-determine the problem. The problem with putting a hinge in here is you end up with two reactions. This bar can't move, so in effect it doesn't need to be there. If I made this hinge, what I'm saying there is that I've got two fixed points, so this bar across doesn't count. So that becomes hinge. Whoops. With just two bars sticking up like that. Okay. So, and you can't solve that problem. Right, so that's why we have the one hinge, and we let the frame work so that it can try and move when we start applying some forces. And what force shall we apply? So let's make this a equilateral triangle, so 60 degrees all the way around, and we apply 12 newtons at the top, like that. I will say that each side of my triangle is 2 meters. Okie dokie. And we will then have this and this, so I'm going to call this A, B and C, and this will be my RAX going in left to right, RAY going upwards, and here we're going to have a reaction of that's going to be the RCY. Okay, so let's solve this problem. So first of all, let's solve our forces going off in the x direction. Oh, I can't see any. Oh yeah, I've got one there. I've got RAX equals 0. Okay. Next, let's solve the forces going upwards. And that's going to be me RAY. 12 is coming downwards, and then we've got an RCY going upwards. So let's rewrite that. Unknowns on the left, RAY plus RCY equals 12. Next, let's take moments. Where's the most sensible place to take moments? Well, it's here. But my force is off in this weird location there. I need to bring it to an x-axis or a y-axis. So I'm going to bring it down and let the force apply here. Okay, I'm just imagining that. It's not really happening, but I'm imagining that so that I can then measure the distance. So what's the distance from here to here? Well, half of 2 is going to be 1. So I can work that out. So that's 1 meter. So we'll take moments at A and we'll go clockwise. So the first force I can see that's going to create a moment is going to be this 12. I'll bring it down to the x-axis, and it'll be 12 times 1. It's a positive moment. And the other one that I can see is this RCY going upwards. It's going to be 2 meters away from A, so that'll be minus 2 RCY equals 0. So pretend I've done a new line. That gives me 2RCY equals 12. Therefore, RCY equals 6. Go back to my equation 1, and I'm going to get that RAY equals 6 newtons. And 6 newtons. Well, you know, I could have told you that. Push down there and it's going to distribute, the load will distribute itself to both supports. 6 newtons going up and up. But at least I've done it formally, as it were. So that was straightforward. Let's do a problem which is a bit more challenging then. So instead of an equilateral, let's do an isosceles. So we will have a triangle here. Actually, I'll make that right angle. Doesn't really look like it, does it? Shall I start again? That's fine. 45 degrees, 45 degrees, there and there. I'm going to have a hinge here on the left again, and I will have a move-in pivot on the right. I'll call this A, B, and C again. So we're going to have RAX going in that direction, RAY going in that direction. We'll have a reaction here of RCY. And for my problem, I will apply 12 newtons and they will go in this direction. So 12 newtons off in that direction. So what do I get this time? So let's go through the process. We'll sum up our forces in the x direction. So this time I can see that we have RAX plus 12 equals 0. Imagine I've done a new line there. And that gives me that RAX equals minus 12 newtons. Okay, so my hinge now from left to right is actually going to give me a value this time. What about the forces now going in the y direction? So they will go upwards. So I've got an RAY going upwards. I can't see any force going there. And then we've got an RCY going upwards. But there's no other forces there, so therefore we've just got an equation. RAY equals minus RCY. And that's my equation 1. Right, well, let's take moments. Take moments, and we'll take moments at A. So we'll go round and we'll go clockwise. So we are gonna go, first of all, let's see this 12. So that 12 is in the middle of nowhere, so I'm going to have to bring it back to an axis. So line of action, I can draw it back here, and then it will hit that y-axis. So the problem is I need to measure this distance here to here. Okay, I actually haven't specified what the lengths are. Let's make this 12 meters at the base, so it's 12 meters from here to here. So if that's 12 meters, let's do a little side geometry triangle here. So 12 divided in half becomes 6 meters. That's 45 degrees. To cut this in half, that becomes my 90 degrees, and that becomes another 45 degrees. Cut 90 in half at the top there. I am interested in this distance from here to here, so I could use cos. So I could, no, I could use sine, couldn't I? no, it's tan actually, isn't it? Tan that I want to use. I've got this distance, and I've got a cos 45. I'm thinking, is there any other things I could use? I'm also thinking I'm being an idiot, because if this is 6 meters, that's 45 degrees, then I know that is 6 meters. Yeah. So this length here has to be this length here for it to be 45 degrees. What a twat. Okay, so here to here is 6 meters. Okay. Right. So we know that we've got a force of 12 going in this direction. It's a distance of 6 meters away from the pivot. So that's going to give me my first positive moment. Here, here it's going to be minus, and actually from here to here will be 12 meters, so that will be minus 12 RCY. Can you see that? And there's nothing else there, so that equals 0. So this, let me arrange it, and we're going to get that RCY equals 6 newtons. Go back to equation 1, and we have RAY equals minus 6 newtons. There we go. So RAY, where's RAY? RAY is minus 6 newtons. That's fair enough because it's a hinge. So we've got this pole, bolt if you like, and it's trying to push upwards. So that's fair. And this one here, the force is pushing into the pivot. So this time we've got 6 newtons and minus 6 newtons. Kind of similar to the other problem in a way, isn't it? Okay. Good stuff. Okay, now what about moving on from triangles? Okay, so I did a solid disc. What about doing a framework? So I did a solid rectangle. What about doing a framework rectangle? So this time we've got members, so sort of planks of wood or whatever, and we will make it into a framework by putting a cross member like that. So you'll notice with our frameworks we're always going to have to kind of boil down to triangles really. So to create a rectangle type shape I have to have 2 triangles like that. So that's all to do with the determinacy, so that so this thing is rigid as it tries to move around. So we'll put in our hinge here, we'll put in a pivot there, and I will make this 30 degrees, 60 degrees, a right angle there, 12 meters bar across, and I will at 45 degrees apply a 12 newtons. So 12 newtons can go there. Right, when you got a problem like that, it's a good plan to split up your 12 newtons into 2 components, an X and a Y component. So if you can do the maths, do the hardcore maths here. If you can't, then put in your calculator as 12 cos 45. Hardcore maths gives you 6 root 2. Okay, in the x direction, and 6 root 2. Okay, in the y direction, that's going to be A, B, C, and D. So we're going to have two reactions here, RAX, RAY, RDY. Okay. You should be able to. We'll stick with hardcore maths. So this is 30, 60. You should be able to recognize that as 30 means that we've got a 2 and a I should be able to know this. So that is I can't remember, it's late, etc. So 12 cos 30, so that's going to give me the 6 root 3 along that side. So if that's 12, so I did 12 cos 30, so I get 6 root 3. Here we're going to get 6. Okay, so this distance here, we'll stick with hardcore maths, is 6 root 3. This distance here is 6, going from there to there. Okay, so we've got the forces here, newtons, newtons, and we've got distances, meters, meters. So I've really labelled up this diagram heavily. Now let's solve this baby. So we've got forces added up in the x direction. So I've got an RAX going in the x direction, and I've got this force, I've already split it up, so I've got plus 6 root 2 going in the x direction. What else have I got going in the x direction? I can't see anything, equals 0. So therefore RAX equals a minus 6 root 2 newtons. Okay, so and that will be, I think, probably about minus 8.5 newtons or thereabouts. Okay, now let's we've gone left to right, let's go upwards. So let's add up our forces going upwards, and that's going to give us RAY going upwards. I've split up my force, so that's going to go upwards 6 root 2. What else have I got going upwards? Got this one here, so plus RDY going upwards. Okay, can't see anything else, so equals 0. So we've got an equation, RAY plus RDY equals minus 6 root 2. That's my equation 1. Right, now let's take moments. Logical place to take moments is at A. So we're going to take our moments at A. You're going to go round in a clockwise sense. So this force here, which is going directly vertically upwards, notice if I pull that back, it will then go through the pivot. So this force here does not create a moment. This force here is going to be perpendicular, and it has a distance of 6. So we've got 6 root 2, that's my force, times by my distance, 6, and it's going to go clockwise. Here we're going to have this reaction here, which is 6 root 3 away, so minus 6 root 3 times by RDY equals 0. Okay, you can see that 6's cancel there. And so that's going to give me r dy. If anyone's clever enough to be at this point, you will see that that gives you 6 root 2 over 3, which equals 4.9 newtons. Okay, so if we wanted to solve the last bit in hardcore mathematics, we would go back to our equation 1 and say that RAY equals minus RDY minus 6 root 2 equals, go back to that number there, so we've got 6 2 over 3, that should be a minus 6 root 2. I don't like the root 3 on the bottom, so I will take that out. So that gives me minus 2, 6. I'm going to split up as in 2 times 3. Bring the 3 in here, so it becomes 3 squared. Cancel 1 with the 1 at the bottom, and then that ends up with minus 2 root 6 minus 6 root 2. Oh, that's kind of pretty. Put that all in your calculator and get a real engineering solution, and that gives us minus 13.4 newtons. Okay, so that's a tricky one. Using hardcore mathematics, avoiding using angles. If you want, try give that go using the angles. Okay. Wonder if anyone managed that one.